This is lecture 18. We're going to deal with the lower leg. In biomechanics, it's called the shank. Not a very long lecture. We're going to look at skeletal and supporting structures. There's the picture of the fibula and the tibia. The fibula is on the outside. So what are the structures on the tibia? We have the condyles. We saw that in the knee, right? Medial and lateral condyles, the flat surfaces. What separates the two condyles is the intercondylar eminence. We have the tibia, tuberosity, sticking out, and the medial malleolus, and the anterior crest. So these are the structures on the tibia. Here are the plateaus, and the intercondylar eminence is sticking up there. That's what separates it. See that? We have the anterior crest. So you run your hand around, down your lower leg, around the shin, you can feel the anterior crest. And then on the bottom, we have the malleolus. We have the lateral malleolus with the fibula, which we'll look at in a minute, but this is the medial malleolus. So because the tibia is on the inside of our leg, it's the thing sticking out from the side is the medial malleolus. On the fibula is the head and the lateral malleolus. So here's the head of the fibula, long shaft, and the lateral malleolus. So when we look at the foot, we'll see how these play a very important role, the malleoli. The superior tibiofibular joint, synovial, non-axial, limited gliding movement. The middle, just like we had the forearm, is not a joint, but it's connected by interosseous membrane. And there's some important functions of this interosseous membrane. See that? The fibers again run upwards from the fibula to the tibia, diagonally upwards, interosseous membrane. The orientation helps resist the pull of the muscles attached to the fibula, just like we saw in the elbow with the radius. It stops the radius from traveling up. Here, it stops the fibula from pulling down. And then we go to the bottom of the tibiofibular joint, and these two fit nicely because of the notch. Now, why do we have two bones in the lower leg? There are three reasons. To grip the bones of the foot, right? The trochlea of the talus. Again, when you look at the structure of the foot, we can see the talus. The trochlea of the talus is wider anteriorly. It's not like a square. Therefore, the medial and lateral malleoli must not only straddle the talus, but adjust to the differences in width. Dorsal and plantarflex, the bones have to expand or contract. So two bones can do that. One bone can't. Second reason, lighter. Two shafts are lighter than one huge big bone. Reason three, two bones plus the interosseous membrane increase the surface area for muscle attachment. If you have a single large bone, what they've drawn in here, but when you have two bones and the interosseous membrane, there's more surface area for muscle attachment. Those are the three reasons. And now we're going to talk a little bit, because we're going into the foot. We've already looked at the knee, the shank, and we're talking about the foot after this. And we look at it in 463, we'll cover it in more detail. But this is an introduction to gait mechanics. The gait cycle. Okay. Now, these things we're going to talk about, right? Initial contact, flat foot, mid stance, heel off, toe off. That's what they stand for. Phases of gait involves constantly changing alignment between the body and the supporting legs. Series of motion patterns performed by the hips, knees, and ankles. And these underlined words Very important. Walking uses a repetitious sequence, right? It's got to be repetitious while simultaneously maintaining stance and balance. So we got to do it over and over, but maintain balance, stance and balance. Each limb serves as a mobile source of support while the other limb advances. And these are the preliminary divisions. I'm going to expect you to know these. When we go 463, we look into it in more detail. Gait cycle, single sequence of movements of one limb. The gait cycle is usually initiated by initial contact of the foot with the ground. Even though they say it's arbitrary, we started by initial foot on the ground, right here. 2 periods of gait phases, stance and swing. Stance, of course, entire period during which the foot is in contact with the ground, begins with initial contact. Swing is the time the foot is in the air, and it's referred to as limb advancement. Swing begins as the foot is lifted off the floor. Stance can be divided into 3 intervals based on the sequence of flow contact. Initial double stance, single limb support, terminal double stance. So, initial double stance, terminal double stance. In the middle, they should not have called it stance. We call it support, which is more accurate. So I want you to remember, we have initial and terminal double limb stance, but in the middle, we call it single limb support. So initial double stance begins when the gait cycle begins, both feet on the floor, also referred to as double limb support, but that's not a good term because both legs are not supporting it equally. Single limb support. Remember, I said not stance, but support because it's supporting the whole body. That single limb, the functional significance is clear. And you see, the book called it single stance, but we don't like that. Support is preferred. Terminal double stance. That's when the other foot is now hitting the ground. Note, single limb support for one leg will equal the swing time of the other leg. 62% on the ground, 38% in the air. The 2 words stride and step, I'm sure you're familiar with them. Just make sure you understand. The duration of a stride is the interval between 2 sequential flow contacts. So, 2 steps make a stride. Time between 2 limbs, there are 2 steps in each gait cycle or stride. Initial contact, foot flat, mid stance, heel off, toe off. So you can see there's a couple of different ways to divide this up. And then I'm going to give you one more, a third division. And this is incorporating some of the things we just looked at. Heel strike, foot flat, heel off, toe off. Heel strike, foot flat, heel off, toe off. And this is a picture. The right leg is just ready to toe off. The left leg, heel strike. And that is the end of the lecture.